are you, everybody who is watching this video? My name is Olenjolai&Nekinyi from beautiful country Tanzania. Once again, I'm at your house, I'm at your car, I'm at your school, I'm somewhere else, or maybe in your mobile phones, I'm in your computer, once again, to bring the good news. And the good news that we have today, it's the one that has been written on the blackboard. We have a good news of Tanzania Online Advanced Secondary School in square bracket Olenjolai&Nekinyi. Okay, so what the main visions of these online schools? The main vision is we wanted to prepare and incubate students, especially that who are in advanced level, who can take the classroom instructions combined with the spiritual knowledge and then solve the real life problems. Because when we say real life problems, some of the problems originate not because of the scientific knowledge, or some of the problems they don't need even mathematics. Some of the problems just they need the spiritual mind, right? Spiritual knowledge that maybe people they have stress of something else that is not going okay, or for example the economics. It can be caused by the spiritual matter. So that's why that we say we like to teach our students to make sure that they have both, and they combine both, right? They combine the spiritual knowledge and the scientific knowledge and mathematics knowledge. However, that I know that many people, they're going to challenge these concepts and this mindset that how comes that you can combine, that because, people, they might say that the spiritual knowledge is far away from the scientific knowledge, or the spiritual knowledge is far away from the mathematics. But I want to tell you the truth is, we have been given both of those situations. We've been given both of those capability to accommodate the informations of the spiritual life and to accommodate the informations of the mind. That's what we call the soul, right? So it means that if we combine, we do great things. And for example, because I know that many people will challenge this one. For example, Joseph, the first prime minister of Egypt, he combined it both. God and read his informations. He combined the spiritual knowledge plus also the physical knowledge. And that's why that he has been a great prime minister and established many laws and many political influence and even many leadership concepts that have been used in different countries. Okay, so we'll be teaching you by using different teaching aids and different teaching methodologies. So stay connected. You'll enjoy the beauty of physics. We'll restore your love to physics. And also we are going to solve many problems as well as we can, and also leave some of the work or some of the assignment or homework for you, so you have to make sure that you do them. Okay? So we are in departments of advanced physics. As I said earlier, that you have to make sure that you watch the session as written, session 00, because you have also our YouTube channel that's called Tanzania Online A-Level Second School in square bracket Olenjolai&Nekinyi, where we used to upload more than hundreds of the videos of advanced level. So we are in advanced physics departments. In these departments, we are teaching advanced physics in Form 5 and advanced physics in Form 6. Or in some of the countries, we call it teaching advanced physics class 13 and advanced physics class 14. So that's what you're doing. That's a great business. And the subject is advanced physics. The main topic is electrostatics, which we broke down and formulated in 5 topics. And we are in the second topic right now of electrostatic force, or force of repulsions or attractions. The class, this content is for the Form 5 class and also Form 5 or class 13, okay? Or even these informations are relevant for the Form 6 students who are preparing for the either mock exams or final exam. And against that, you have to make sure that you have your syllabus beside you, and also you have any textbooks at least beside you, and also you have to make sure that you have question and answers for instance, at a review book or some past papers around you which contain questions of electrostatic. So you'll be assessing yourself and assessing how are we going through. One. So the quick review, right? The quick review of session what? Of session 04. Basically, we've been solving. So what we have done there, basically, we have been employing the fundamental law. We have solved some problems, okay? That employ fundamental laws, okay? Fundamental laws. That's what we have reminded you. And also have reminded us about Coulomb, right? Coulomb's law, right? And solve some problems. So again, so you did problem solving, right? Problem solving or not on these 2 laws, fundamental and Coulomb law. Again, we related the electrostatic. We taught you the relationship between electrostatics, okay, and what in mechanics, okay, and especially that the concept of resolving forces, right? So it means that we say, for example, we have some pointy charge which have been suspended by the threads, like this one, that this is Q. So this is Q1, let's say, and this is Q2, and there's a distance of separation here. But the angle can be made like this one. So then you find that we have a force of repulsion, if this is a like charge. Then you have the vertical components of force, you have horizontal components of the force, and also you have another horizontal components of the force, right? And we left him a homework which was question number 3. So it was example 3. So I believe that you have done the question. So I'm waiting you to submit in the comment sections. In case that you find some troubles, then I can assist you, right? So today we have another principle, or we have a principle that's called the superposition principle of electrostatic. Say superposition principle of electrostatic. So say superposition principle of electrostatic. Okay. So before we state this superposition principle, we want to show, we want to present to you the demand. Why we need this principle, right? Where are we going to use? That's the point. What are we lacking from the other laws, fundamental and Coulomb's law? So in such a way that we need this superposition principle, right? So the issue that we say that if if we are given two charges, if we are given two pointy charges, right? 2 point charges. So we say that the electrostatic force, when we say electrostatic force, means that attraction or repulsion, attraction or repulsion force, right, can be found, right? Can be found by what? By using fundamental to know the direction, whether it is fundamental laws, right? Fundamental law and the Coulomb and Coulomb's law, right? And Coulomb's law of 14 of electrostatic. What does it mean? We have 2 pointy charge, right? So we dealt with this concept. So suppose that this is Q1, which is positive, and this is Q2, which is negative. So this is the center of this charge. Then sub the center of this charge. So we have a distance between these 2 pointy charges. So the distance is R. And then so we have that Q1, as I said, that's Q2. So we say that here we are going to have force of 40, so we also have force of attractions. So we have force of attraction. So these 2 charge will be attracted because they are like charge. So according to the Coulomb's, the force of attractions in magnitude, the magnitude of the force of attraction will be equal to the proportionality constant times product of proportionality constant times quantity of 31 times quantity of 32, and then she said that you have square of the distance, like that, right? But again, you have to include the concepts of medium, which you have epsilons, which is what permutator 40 of the medium. So this is in case that we have 2 point charges which are either in free space or in another mediums or in another direct with may affect any paper or in aluminium affect in electrolytes. So it depends. But this is what we have been teaching, right? So we have a problem now. Okay? We have a problem. So this is the problem now. So we say that let me just state that the problem statement. Okay? Problem statement. So how do we compute the electrostatic force? When you say electrostatic force, it means electrostatic force of a point, electrostatic force acting upon a pointy charge due to many due to number of other pointy charge at the pointing number of, means that many, due to many, so you can say number or many other pointing charges surrounding it, surrounding the given pointing charge. Okay, the given pointing charge. So you say, how do we compute the electrostatic force acting upon a pointing charge due to the many other point charges surrounding it? Surrounding it. What does it mean? Suppose that we have a pointing charge here. So you have a pointing charge. Let's say that this is the pointing charge. We call it Q1. And then again we have another pointing charge here. Then you have another pointing charge somewhere here. Then you have another pointing charge here. Then you have another pointing charge at this place. You have another pointing charge here. You have another pointing charge here. Right? So you have another pointing charge here. Right? So all of this force, all of this one, there is the force A is of repulsion or attraction that's going to act upon these point charges. Suppose that this Q1 is positive. So here we have positive, let's say Q2, then we have positive Q3, then we have negative Q4, then we have positive Q5, then you have negative Q6, then you have positive Q7, then you have negative Q8. Again, we have radius, so let's say that this is R2, this is R3, this is R4, this is R5, this is R6, this is R7, this is R8. So our main objective, we want to know what is the resultant electrostatic force acting on Q1. So because at this moment, or at that, in that situation, the electrostatic force acting upon acting upon Q1 is not, we just say that it means that the electrostatic force acting upon Q1 is originating from different point charges. It's not like in this situation, right? So how do we answer that questions? Okay, so we say that the electrostatic force acting upon a pointing charge, okay, upon a given pointing charge due to several point charges, can be found by using the superposition principle of electrostatic. Because there is superposition principle also of wave. Okay? So the fundamental question now which comes into play is another question that states the superposition. Before we show you the mathematical formula of that situation, say the superposition principle of electrostatics. So I like to state state the superposition principle of electrostatic. State the superposition principle of what? Of electrostatic. Okay. So we say that the superposition principle says superposition. The superposition principle of electrostaticity state that when a number of charges when a number of charges are present, the total electrostatic force when a given charge is equal to a vector sum of electrostatic forces electrostatic forces due to the other pointy charges. With the other pointy charges remaining on a given charge. Charges. It's the end of the quote. Let me explain. The superposition principle of electrostatic states that when a number of charges means more than one charge, right? That means of number of charges are present where in a certain medium, whether the free medium, the free space, or any other medium, the total electrostatic force on a given charge, on a certain charge, is equal to the vector sum. Say vector sum. Vector sum, very important vocabulary. Vector sum of electrostatic forces due to the other pointy charges remain on a given charge. What does it mean? The electrostatic force, the resultant electrostatic force acting on pointing charge Q1 will be equal to the vector sum of 40 of all of these electrostatic forces are impacted or caused by the other pointy charges that is surrounding this pointy charge, which is Q1. Right? So that's the concept that you have to understand. So it's the vector sum. When we say vector sum, means that first of all, that force should have both magnitude and direction. And also when you say vector sum, means if it has a magnitude and directions, and even that according to the spacing of these pointy charges, it means that you can have horizontal components of the force and vertical components of the force. Right? So that's what you expect. So that's why we need a sum. Okay? So that's why we need a sum of 40. We need a sum of the pointy charge. So then we say that the individual forces between between the given charge and the any other charge and any other charge and any other charge is computed or is found by using the Coulomb's law of electrostatic. What does it mean? Listen carefully. This means that, for example, if you need the force of attractions, whether horizontal components or vertical components, which is F2, between Q1 and Q2, then you're going to use the Coulomb's law of electrostatic. Similar, if you want to find the force of attraction between Q1 and Q2 and Q8, we are going to employ the Coulomb's law of electrostatic. But when you are going to employ the Coulomb's law of electrostatic, because these charges now are not aligning on the same straight line, so you have to take consideration that for instance for this one, it contains the horizontal components of the force and the vertical components of the force, because the line is diagonal. So it means that it's above the horizontal line. Right? So that's the concept that we say that these individual forces, we use the Coulomb's law of electrostatic. But now to find the resultant force, we use the superposition principle, which gives us the vector sum of electrostatic forces acting upon the given point teacher, which is Q1. Right? So it's well understood. In case you have any question, don't hesitate to yourself to ask in the comment sections, so that I will come back to you to clarify about that point that you maybe have got to stack off. Do you enjoy the beauty of advanced physics? Do you enjoy the beauty? Okay, again, in case that you feel from your heart that you want to offer God the thanksgiving in order to make many lectures or many videos of electrostatic to be in air. So you may yet send you a thanksgiving offering. So this mobile number 0759 745331, and your thanksgiving will be received with the hand of thanks, and will be used effectively to pay for the running cost for this program. Again, we can state this superposition principle like this one, or superposition principle state that, so you can state it as every charge in space, creates an electric field. What are the use of electric field? These are the electric field lines. So it's just like what you say about force, mean that the force is presented by using the electric field lines at a point, okay, at a point, independent of the presence of other charges, in that medium, And this, the electric, so it's say that the resultant electric field, resultant electric field is a vector sum of the electric field. Electric field due to individual charges. That's how we can state principle of superposition principle. So here we stated the superposition principle. Don't underline, just unless as one of the keyword. Listen carefully. Here we stated the superposition principle in terms of electrostatic force. And here we've stated the superposition principle in terms of what electric field. So the next topic after this, electrostatic force, it means that it will be electric field. So this topic of electric fields, what does it mean? Listen carefully, because I want to give you the fundamental concepts. For instance, we say that this is the positive charge, positive Q, and this is the negative Q. So this is Q1, this is Q2. So unlike charge, attract each other, right? So it means that we have a distance between the centers, because these are the centers. So there's a distance between these two centers of these 2 pointy charges, which is R. So what happens, right? So it means that if you do an experiment and examine this force, you'll find that there are field lines, right? For instance, that we say that we have field lines. Then this one is another field lines. And this is another field lines. This is another field lines, right? So these are the field lines. So this is what we call the electric field. Okay? And then here it is, right? Then here it is. But these are directional electric field lines. Let me check the directions, whether from negative to positive or positive to negative. So, yes, so it is positive is the one that provides a negative is receiving. So from positive to negative. So this is positive and this is negative. So this, the direction of these electric field lines will be this way, right? So these are electric field lines. So listen carefully. And this is the point charge 1, point charge 2. So these electric field lines, what do we say that? We say, okay, fine. So if this is the situation that we have, what's going on there? Okay? So you have to think a moment. So we say that the electric field, which is E, if we want to find its magnitude, because even itself is a vector quantity, this will be equal to the force of order over the pointing charge. And you know that also even force is a vector quantity, so we find its magnitude. So magnitude of force over the pointing charge. What does it mean? For example, you want to know the electric field strength acting upon Q2 due to the Q1, right? So it means that that is equal to the ratio for electrostatic force of attraction between Q1 and Q2 divided by the point charge, which is Q2, which is receiving that force, right? Okay. Okay, so that is what going on. So that the means of electric field strength. So you say that even itself also, so at a point independence of the presence of the other charges. So you have several charges. So this is in case that you have 2 charges. But remember that in case of superposition principle, we have several charges, right? Surrounding one charge. And then that the means of that every charge in a space creates an electric field at a point of what independence of the presence of other charges in that medium. So the resultant electric field, in this case you say the resultant electric force is what? Is a vector sum. It's a vector sum of what for electric field. It's a vector sum of what electrostatic force. Right? And then it's due to what? Due to the individual charges. And this one due to the other point charges remaining on a given charge. Right? So this is the concept of superposition principle in terms of electric field strength. Means we won't waste the time on stating the superposition principle for electric field because we've already stated. Right? We want to give you the big picture because in many cases you find that the questions, even the sentences will be in terms of electric field. but you cannot learn a course of electric field if you don't know the electrostatic force of attraction or repulsion. That's why that we have to cover Coulomb's law before this. Okay. So then before I present some of the applications of this superposition principle, then we can say that we can go back to our problem and see how we can deal with this. So we can see that some of the applications of superposition principle, for example, that mathematically, then we say that mathematically we have one point charge here. This is Q1, possibly positive. We have another point charge. This is Q2. We have another point charge. This is Q3. We have another point charge. This is Q4. We have another point charge. This is Q5. So then we have a distance, and here we have another distance, and here we have a distance, and there we have a distance. This is R2, this is R3, this is R4, this is R5. And then she said that this is the point. So this is R6, this is Q6. Okay. So we say that the individual forces between Q1 and Q2, we found it by using what? Coulomb's law of electrostatic. So for instance, for this case that we say that if you want to find, I mean that in generally, so this is generally, we don't consider the horizontal and vertical component. So we say that generally, so we say that the force of attraction, this is equal to K, Q1, then so to Q2, over permittivity of the medium. For instance, it's air or whatever. But that's why we have K. So K, it means that you know it's 1 over 4 pi permittivity of the medium, right? And then so this one over R squared. So then we say that by using superposition principle, so this is generally, so the force acting on Q1 is equal to what? Is equal to K, Q1 times Q2 over R2 plus K times what? Q1 times Q3 over R3 square, then plus K, Q1, Q4 over R4 square, then plus what? Plus K, Q1, Q5 over R5 square, and then she said that plus what? K, Q1, Q6 over what? R6 square, right? So what is common there? Q1 and K are common. So the force we act upon Q1 is equal to K, Q1, and then she said that this is what? Okay. So he said that this is what? So this is Q2 over R2 square plus what? Q3 over R3 square plus what? Q4 over R4 square plus what? Q5 over R5 square. Then we say that plus what? Plus Q6 over R6 square. So this is what we expect to have, without, if we ignore the issue of horizontal and vertical components of force. But the superposition principle will involve the horizontal and vertical components that we are going to deal with. Well, so then now we have another question. What are the applications? Where do we apply? What are the applications? What are the applications of 40 of superposition principle? What are the applications of superposition principle? So you have a number of them. So he said that superposition principle have many applications in electricity and magnetism. Such as the first application, this principle it is used to find net force. When we say net force, it means the resultant force. Net or resultant force. Resultant force at the first application. If you have any question, don't hesitate asking the comment section, and keep enjoying the beauty of advanced physics, especially in terms of electrostatic. Second application said that it is used to find resultant or net. Resultant. It is used to find resultant or net force. Net force, net field. Net field strength. Okay? Net field strength. Okay, net field strength. So net resultant field strength. Resultant field strength. The second application, we say that it is used to find the resultant electric potential. So electric potential. So it's used also to find the resultant electric potential. Okay? That's also its electrostatic. But also it says that it's used, superposition principle is also used to find what? Resultant or net. Resultant or net what? Net electric flux. Electric flux. So this electric flux is the symbol for electric flux. Okay? It's a new terminology for you, but we're going to cover it. Because we're going to have electric flux, we're going to have magnetic flux. Okay? The first application of superposition principle in physics, we say that match potential energy to a number of the charges. So also this superposition principle is used to find the resultant or net electric potential energy. Electric potential energy. Okay? Of 40 of several point charge. Several point charges. There's a difference between electric potential energy and electric potential. Electric potential is not electric potential energy. So you have to understand there's a great difference, just like in gravitation. Gravitational potential is not equal to gravitational potential energy. Those are the two quite different terminologies. Okay? However, that you can relate them. If you have any question, ask in the comment section. Okay, I will be happy to hear your question. Okay, so after presenting those few applications, Now I want to take you on to the very interesting part of superposition principle, which is kind of deriving now the formula. And this part we call it magnitude. Say magnitude, 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 and what? And the direction, magnitude and direction of 40 of resultant, magnitude and directions of resultant force, resultant forces. Also, you can use these concepts, and we can call it. You can use in the concepts of the topic of electric field. So you can deduce the magnitude and directions of resultant electric field, right? Or even you can use the electric potential, and you can call it magnitude and directions of 40 of electric field strengths, or of resultant electric field strengths. Okay? So the magnitude of resultant force acting on a given charge due to the charge configurations is the vector sums of horizontal force and the vertical force. So that's the point. What is magnitude of resultant force? That's the question. Okay? What is magnitude? What is magnitude of 40 of resultant force? Resultant force. Okay? So we say that the magnitude of resultant force, we say that of the resultant force acting on a given, the magnitude of resultant force acting upon the given pointing charge, the given pointing charge, due to the charge configuration, 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 right? This charge configuration, you say that with the vector sum of what? Of horizontal component, which is x-axis, component of force, with the force along x-axis, and the vertical components of force. Physics is beautiful, electrostatic is beautiful, so stay connected. So we say that in the vector sum of horizontal component of force, which is x-axis, and this, so this is NB, and the vertical component. So in vertical component of 40 of forces. So in vertical component of force. So that is what we call the magnitude of resultant force. Magnitude of resultant force. So it's the vector sum of horizontal force and vector components of force. So it's a vector sum. So what does it mean? We say vector is a vector quantity. So now force is the vector quantity. So we say that the magnitude of vector quantity, which is called the force, this will be equal to, we use a distance formula, to the square root of what? Listen carefully, stop writing. Square root of what? Summation of the force along x-axis square at the means of vector sum, so it's a sum, then plus, open bracket, summation of what? Of the force in the vertical component square. Separating and saying. So what does it mean? So it means that sometimes you can have that in xi, so from I is equal to 1 to n. And sometimes also you can have yi, so you have I is equal to 1 to n. I don't worry about that, those notations. Simply can say that, simply can say that it's a force, magnitude of the force is equal to square root of what? Horizontal summation of horizontal component of force square plus what? Summation of force in vertical components like this. So this is the general formula of computing resultant force in electrostatic. How can we find those components? So the magnitude of the resultant force on a given charge, whereby summation of this and this is called the summation of 40 of forces in the horizontal component. Summation of forces in horizontal axis, which is x-axis. Then we have against another component, is a vertical component, F1. So this is equal to summation of what? Of forces in vertical axis. So vertical axis, and this one is for horizontal axis. So we can present those summation of the forces in X-ray plane, so you can get them. Okay, so geometrically, using XY plane, okay, so geometrically we have this situation. Suppose that we have a resultant force, represent from ridge like this. So then this is like this. Okay? So then, so if that's the case, okay, so then we say that this is horizontal components. So here we have summation of horizontal components of force. Okay? Against this, the vertical. So we say that we have summation of horizontal components of force. Okay? Again, if this is the resultant force, resultant force. So because that is the resultant force, here we have an M, which is the angle theta. Right? So you can even find a resultant force okay. So this is the resultant force. So even if that you want to use the constants of isogras, you can deduce this formula. How? The resultant force Fr square is equal to what? So this is equal to the summation of horizontal component square plus summation of so you see, so you can use also the concept of isogras to use that formula. So by using that formula, it means we use always to find the resultant force. So it will be square root of what? Of so plus what? And this one is summation f of y square. Right? But our intention is just wanted to show you that you can also derive the same formula geometrically if you understand the triangles. Again, we need the concept in our subtitles. In previous subtitle, we have written magnitude and direction. Direction of 40 of resultant force. Resultant what? Directions of resultant force. Directions of resultant force. Directions of resultant force. When you say direction in mathematics, in basic engineering and scientific mathematics, you mean that angle. Say angle. So angle, that's what you mean about direction. So for this case, if you consider that this is a triangle or PQ. So he said that in order to get direction, we have to say that we have to consider right angle triangle, or PQO. So consider the right angle triangle PQO. So when you consider, you say that tangent tan of angle theta is equal to tan of angle theta is equal to tan of angle theta. This is equal to what? This is equal to the summation of summations of vector sum of vertical components of a summation of x. Right? So what does it mean? We say that tangent of angle theta is opposite of adjacent. So to get the direction which is the angle, it's simple. Direction of what? Direction of a vector. No, directions of resultant. ratio of resultant force, right? So this one we'll get by taking theta tan inverse of what? Summation summations of this guy over summation of this guy. So this is tan inverse of what? Summations of horizontal of ratio of sum of vertical component over sum of horizontal component of force. So you say that this is the direction. So once that the question asks you that find magnitude and direction, then you have to remember this formula. So finding the angle, first of all, needs us to find the summation of what? Vertical components of force. And find summations of what? Horizontal components of the force. If you fail to find either of these, then you'll be wasting our time. Okay, so that is all about the magnitude of force or magnitude of resultant force in this direction. Now, I want to take you into another perspective of electrostatic, which I want to present for you comparison between electrostatic comparisons between electrostatics and gravitation, okay, and gravitational effect, gravitational forces. Gravitational forces. So let us read that subject: comparison between electrostatics and or electrostatic force and gravitational force. So just to make a point here, so comparison between electrostatic forces and the gravitational forces, right? Gravitational forces. Gravitational forces. So when you say comparisons, what do you mean? We have to examine the similarities and what differences. Comparisons mean that There's two meanings for comparison. Number one, comparison means that you have to study about what? Similarities. Similarities of what? In that case, of electrostatic force and the what? Electrostatic force and the gravitational force. What are the comparisons? What are the similarities? There's some of the similarities. What are they? Right? Again, the quality of comparison means also you have to mention there are differences. Differences between what? Between the electrostatic force of attraction or repulsion and also gravitational force. And that and the so there are some similarities and differences between electrostatic force and gravitational force. So I will be presenting to you the similarities between what? Electrostatic force and gravitational force. And then I will leave the differences between electrostatic force and gravitational force as your homework. Why? Because I've already told you about the topic called the gravitation, so you know about gravitational force. And then now I've taught you about electrostatic, so you know too much about what? Coulomb's law, electrostatic, etc. So you know about the electrostatic, the nature, whether it is attractions or repulsions, so you know a lot. So then, we say that similarities between electrostatics, statics force, and the gravitational force. And the gravitational force. So similarities between electrostatic force and gravitational forces. I have some similarities which I want to present for you, and then I leave the homework for you, and then it will be the end of this session. Right? So the first is, so you have how many? I think that 5. Yes, 5 similarities. And hence you also have to look for 5 differences between the two types of forces. Are you ready for that? Some other students say no, that they will tell in the comments, excuse me for your homework, I haven't learned about gravitational force. And I will answer that now. There's no excuse for my homework. Okay, the first thing, we say that the first similarity, we say that both gravitational in the priority in the electrostatic force. In the electrostatic force. And the electrostatic force obey the inverse square law. Or the use of inverse square law. The force of attraction is called repulsion. So most gravitational and electrostatic forces obey the inverse square law. So you see that the force of attraction, so the force of gravity between the two heavenly bodies or large bodies, this is always the portion of the square of the distance between them. What does it mean? For instance, that suppose that this is the satellite. So you have satellite. Okay. And suppose that here we have moon. And you have a distance between these centers. Then we have distance, which is r. As is from perspective 40 of gravitational force. Satellites, moon, that is gravitational force. Right? Distance between them is r. Okay, so this is supposed to be mass 1. This is also mass 2. Right? For that case, that the force of attraction between the satellite and the moon is equal to what? Okay? Q1. Okay. Excuse me. This is for electrostatic. So according to Newton's law of universal gravitation, we call Newton's law of universal gravitation, state that we have universal gravitational constant times mass 1 times mass 2 divided by what? Square of the distance. Right? And also, when we discuss about electrostatic, say that suppose that this is Q1, which is positive, and suppose that this is Q2, which is negative, and the distance between them is also it is r. R, so you have Q1, Q2, and then we say that, okay, we need to say, okay, we have to find the force of 40, for this case, attraction force, the static attraction force. So we say that this is equal to K, Q1, Q2, of what? Over R squared. Right? So this is from perspective of gravitation, this is from perspective of 40 electrostatic. So you see in this equation 1, the force of attraction is inversely proportional to the square of the distance. Right? All together. And we come at this point also, the force of attraction. Force of attraction for this case also, this is inversely proportional to it. That's why we say that both gravitational and electrostatic forces obey the inverse square law. So these two are what we call the inverse square At the first 30, similarity. Follow along. It's the common question in exam. The second similarity. Tell your neighbor second similarity. Tell your neighbor second similarity. So the second similarity says that both are central forces. Both gravitational force and that electrostatic force are what? Both are central forces. So he said that both are gravitational force and the electrostatic force are central forces. What does it mean? Central forces mean that we say that to say forces act along the lines joining the centers of the bodies. That to say that forces these two forces are what? Forces acting along the line joining, acting along the line joining acting along the line joining their centers. What does it mean? For example, in case of electrostatic, we have listen carefully. This is nucleus, and this is possibly the nucleus. Then this is called anyway. So we say that the force of attraction is this is Q1. Jojo. What are you doing, Jojo? So this is Q1, for instance, and this is Q2. Positive or negative. So he said that these forces act in the center, not on the circumference of the pointing charge, but these forces act in the center of this point charge to the center of this charge. That's the meaning of 40. Both gravitational force and the electrostatic force are what is central forces, right? That's the meaning. Then the third is similarity. Both are the consecutive forces. Let's say work done by them does not depend upon the past followed. Both are consecutive forces. Work done by them does not depend upon the past followed. That say that the work done so you say that the work done by them does not depend upon the past followed. Work done by them does not depend the past followed. Other two similarities. As followed. The first one, we say that most forces involves the property of intersecting intersecting particles. So it involves the property of intersecting particles. So most forces involve the property of intersecting particles. What does it mean? We say that the way that these forces or particles and the mass in one case and the charge in another case. So it means that there's an inch of distance between them. So if this distance is reasonable, you find that the force of attractions, because for instance, you have maybe a certain point charge of a certain magnitude. So itself has been surrounded by the electric field. Right? So you say that this is at the electric field lines. I'll teach you later. Right? Again, to meet you is another one. Okay? So it means that if we bring this charge and comes to this point, you find that there are electric field or electric force between these 2 point charges. So it means that now they've already intersected because this Q1 is within the region. Right? What does it mean? For instance, if you have a positive charge here and have a negative charge here, because of the distance they won't intersect. Right? But if you bring closer and closer at this point, you find that if this intercepts, all the electric field is passing by yours. Right? At the means of 40 of intersecting. Okay? The first and the last similarity is this. Both forces can operate even in vacuum or in air. So both forces can operate, both of these forces can operate even in vacuum. So vacuum means about air. Okay? So homework, because I know that this is the good time now for students to hear that the sessions is going to end. Whether they understood or not, always students like to relax. Briefly, explain 5 5 similarities, 5 differences actually. 5 differences. So briefly explain 5 differences between gravitational force and the electrostatic force. So I've explained the similarities. So briefly explain 5 differences. This is 5. Let me write. Because some other students can write 1 instead of 5. Okay? Briefly explain 5 differences, plural, between gravitational force and the electrostatic force. If you do that, then you are closely to understand the concepts of electrostatic. Okay, that is the good news that God has prepared for you in session 5 of electrostatic. Thank God who have been with me during the preparation of this session. There are 2 and other sessions always, because I want to make a new history for the present and future generation. I thank you also for taking your time and joining me in this session 5. I believe that you've learned something, in case that you need to understand some of the concepts. The good news is you have a video. You can go through it at any time and anywhere. So you can revise several times as well as you can until this information has been written in your subconscious mind or in permanent memory, where that you won't forget. So I would like to thank you in advance for taking this chance. Use the comment section below there, ask you questions and even answer questions that other students have asked you. Also make sure to click the buttons that is being written subscribe, so that even if we upload session 6, session 7, 8, 9, 10, 11, 12, 13, 14 for electrostatic, the YouTube commentary will give you official notifications. Again, share these contents with your classmate, with somebody else that who is in this level, so that they may enjoy the beauty of advanced physics. Right? So again, remember that the main or the visions of this program is to make sure that we are teaching you to think differently, how you can take the classroom instructions to solve a real life problems that are waiting you, because you are born to solve a problem or problems. So there's a number of problems that are waiting for you to graduate your studies, and then you have to go back to solve for that. It's not just going back to look for the employment, but go back to solve a real life problem. So thank you very much. May God bless you. See you in the next session.